Greetings and welcome, friends. Mr. Waddy and my algebra buddies in real life. We are going over some of last night's quest, which was vertex form of a parabola. It's the best. Oh my goodness. So let's start by figuring out what A, H, and K are. So A here is going to be a quarter. H is going to be the opposite of this 10, so negative 10. And K... guys, the K is gone. Someone stole the K, but we have a way to represent nothing in math. We call it 0. So negative 10, 0, so I can plot that point right here, like so. So in terms of the sloppy slopes, right, hopefully you guys are getting good at these slopes, quote-unquotes, of parabolas. We normally would go up 1 over 1, up 3 over 1, up 5 over 1. But I'm going to now multiply all of these numerators, all of the rises, by a quarter. So a quarter times 1, and a quarter times 3, and a quarter times 5. Quarter. So 1/4 over 1, 3/4 over 1, and 5/4 over 1. I'm intentionally not reducing these fractions anymore, because this is my rise, this is my run. And if it was a line, I could reduce these fractions and it would work. But for slopes, no, it does not. So because this is fourth, I'm going to use this denominator to subdivide my y-axis and count by fourths. So notice, here is the 1. Here is 3. I already kind of spread this axis out, stretched it a little bit. But now I'm going to... divide this up even further. So here's the half mark, but I want quarters, and a quarter is a half of a half. So let's add some more tick marks here, shall we? And if I count by fourths, moving up 1/4 or 3/4 or 5/4, it's going to be quite easy. I think that's all I'll need for now. So let's, starting from our vertex, we'll move up a quarter and over 1. Right, so I moved up a quarter height, and then from there I'd move up 3/4 and over 1, right there, and then up 5/4, right, and over 1. So by changing my axis, I can actually plot these super easy. And hey, actually, we've got the space. Let's do it. Let's go up 7/4. So that's going to be 3.5 grid spaces. 7/4. And over 1, right? So I can do that just like so. The axis of symmetry is going to be x equals the x coordinate of the vertex, so x equals negative 10. So let's draw that so we can do some mirroring. Mirror! All right, so let's mirror some of these points, and we can get so many points. So many points. Oh yeah. I actually have a shirt that says Division 1, like, in terms of athletics, but I like to tell people it's my favorite operation, which is actually not true. It's not my favorite operation. What is... Yeah, I was playing the Division the other day, Tom Clancy's. No. So here we go. So here's our parabola. I've graphed it. They said also compare the graph to the original function. So this A and this H, the H results in a horizontal shift left, right? Because it moved it left 10 units. Left 10. And then the 1/4 was a vertical shrink, or smoosh, schmoosh, 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 by a quarter. And I'm just glad to have a fraction that's not like a half, because I feel, or a third, I feel like we did a bunch of those. So there we go. That's how you graph these parabolas. Let's jump into some of these other problems. So here we go. I'm going to actually analyze all of these real quick for us. Let's see. So for the vertex on this one, it would be -1, -3. The vertex on this one would be the opposite of that one, so +1, +3. The vertex on this one is going to be +1, +3. Remember, it's always the opposite for the H. Oh, we'll analyze that as well. That's a good idea. Actually, let's see if we can, let's see if we can analyze it just based on up or down. So this one has a negative A value, so what does that do, Brandon? It opens down. This one opens down. This one opens up, and this one opens up. All right. What? What doesn't work? Well, I haven't selected my answers just yet. So let's see. So -1, -3, -1, -3, -1, -3. B or C both have a vertex of -1, -3. But which of them opens down? C. So it looks like 35 would be C. All right, so I've just eliminated that from my possibilities. This one is at 1, 3. This one has a vertex at 1, 3. This one has a vertex at 1, 3. This one opens down, so this one must be A. All right. And then let's see, 1, 3. Oh, that was the other one, and it opens up, and it's a third, so that's why it was a vertical smoosh. So 37 is D. And then let's just verify that 38 is going to be B. So -1, -3 for the vertex. It opens up. It also was a vertical stretch by 2. That is B for sure. So that's how you can do those problems, kind of analyzing the vertex. We also could have analyzed stretch or smoosh, and you can tell a little bit by the shape here. At least for their graphs, they don't change the scale on the axis, so I guess like a smoosh is a little bit more obvious compared to a stretch. Whereas since I distort my axes whenever I graph, my parabolas are kind of the same shape-ish every time. You just got to pay attention to the fact that I changed the axis there on us significantly. All right, last problem I'm going to do for the homework today is 41. All right, well, let's write it down. Follow along. So A is going to be the 4. H is going to be +1, remember? And K is going to be -5. So my vertex is at 1, -5. So over 1, down 5. Looks like my scale is normal on my grid. Does this open up or down? Why? Because A is positive, so it's going to open up. Looks like I gave myself plenty of space here, I assume. I also expect that it's going to be skinny because it's been vertically stretched by 4. Which, by the way, right so far I've been giving you the coordinate planes for your graphs. But one of the things that eventually you guys should learn to do, I guess maybe even an Algebra 2 thing or something, is that you'll need to be able to know where you'd want your graph or your window for your grid to land in the first place. And so based on where the vertex was and which way it opened and that it was a stretch, right, I kind of visualize, okay, so I'm going over 1, down 5, and I'm stretching it and moving it up. I kind of can visualize where I want my window to focus. Because it's a little bit weird to have to like commit to your graph before you even graphed it. So that visualization piece is going to be important. But right now I've been fine giving you your pre-made windows. So the slopes. No, because I guess like because of my window, you would assume that it doesn't open down if I gave you all the space up there. So that is the unfortunate thing. By me choosing the window for you, I do give information away a little bit by doing so. So yeah, so that is a skill that I've got to have you guys learn at some point, but maybe not now. Yeah. So we're going to go up 4 over 1, up 12 over 1, up 20 over 1. We'll see how much we can even fit in here. Oh, it looks like I'll fit it. So up 4 and over 1, plot a point. And then up 12 is going to bring me all the way to positive 11 and over 1. Let's see. Anyone help me with the axis of symmetry here? X equals what number? What would the equation of the axis of symmetry be? No. Right, visually, we know it passes through the vertex. Where do I pull the axis of symmetry from, guys? No. Alright, someone else help him out. Tag team. Yeah, it's going to be the H, so it's going to be x equals 1. So it's the x coordinate of the vertex. No worries. So now I can mirror those. Mirror and mirror. And let's see. I'll do the flip the canvas. Let's see how well I can do it. I had a hard time the other day flipping the canvas. Whoa. Whoa. Alright, so let's like that, and like that is roughly where my parabola is going to land, and based off of 5 points in our understanding of what parabolas look like, you can usually draw a pretty good sketch like so. So thanks for watching, Internet friends. Have a great day.